Hey guys, here's a video to walk you through how to find the derivative of an inverse function at a particular value. So if g is the inverse of f, and this is the notation for inverse, then the derivative of g at a particular value a is going to be 1 over the derivative of f evaluated at the inverse value at a. So let's talk about all those puzzle pieces, and then we'll do some examples, see how it goes. First thing you need to remember, if you were originally going to try to find an inverse, that's where you would sort of switch x and y, and then resolve, for y, and that would be the inverse function. And if you remember back from algebra, that would be where the graphs actually are reflections of each other over the line y equals x. So I'm not going to go into the whole backstory of inverse. I am going to upload a walkthrough of the proof for this equation. But if you need just help with the overall idea of inverses, just let us know. But the puzzle pieces are this. You're going to be looking for the derivative at a single value. So you're not actually going to need the derivative of the function itself, the inverse function itself. You're just going to need the derivative evaluated at a single value. Okay, and then you're just going to take the reciprocal, so 1 over. You are going to need the derivative of f, which is going to be fine. We already know how to do lots of derivatives for an original function. And then this part right here is going to be kind of the key part too, is figuring out what that value is. And we'll talk about that when we do an example. So here's your first one, just to kind of show you the ropes. Let's say you have this function, and g is the inverse of f, and they're asking you for g prime of 3. All right, well, again, if you were going to try to find the inverse function yourself, you'd literally have to, I mean, this is y equals, right? This is the same thing. You'd literally switch out x and y and then resolve. But what I'm saying is this formula, you don't even have to do that. In fact, there's going to be ones where you can't even solve it algebraically. This one we could. We could subtract 2 from both sides and then take the cube root of both sides and then resolve. But what I'm saying is you don't even need to do that if you follow this formula. So what do? Well, g prime of 3 is going to be 1 over f prime of g of 3. And now we got to figure out what g of 3 is. So normally we plug a number into the function and figure out what that value is. So like you'd want to plug in 3 here. But that's not f of 3 that it's asking for. It's asking for g of 3. So instead of plugging the number in for x, you're actually going to set this equal to that number. So 3 is going to equal x cubed plus 2. And that's going to allow us to figure out that single value. Now, some of these you probably could do just by inspection and be able to figure that out. But this is the algebraic way you would do it. And if for some reason algebraically you couldn't do it, you could graph these two and just see where they crossed. So we could just subtract the 2. So 1 equals x cubed. So then x, of course, equals 1, which kind of makes sense. If you plug in 1, you're going to get 3. So if the value of the function is 3, the x value would have to have been 1. So I'll say that another way. If I were to plug in 1 here, I would get 3. F of 1 is 3. G of 3 is 1. Okay, so G of 3 is 1. We just figured that out. So then to continue with this, we would have G prime of 3 equaling 1 over F prime of 1. And now we just have to find F prime. Well, F of x is x cubed plus 2. F prime of x is just 3x squared, right? So that means f prime of 1 would be 3 times 1 squared, which is 3. So then this becomes 1/3. So the derivative of the inverse at 3 is 1/3. And that's sort of the process that you'll need to be able to do. And again, the sticking point is probably just going to be this part here, because you're going to be able to find the derivative of f pretty easily using our normal rules. But finding the inverse value, a lot of times people just end up plugging in to the f function, but that's not what we want. We want to plug it into g, not f. Okay, let's do another example. Keep the formula up there. Let's do, suppose f of x is x cubed plus x, and we need to find g prime of 2. And again, in order for this to work, g has to equal the inverse of f, which it has to be given. If you don't have this as your given, then you're not really going to be able to use this formula. All right, so give it a shot. Let's see what we get here. So g prime of 2 is going to be 1 over f prime of g of 2. So our focus right now is going to be to find g of 2. And again, we're not going to plug 2 in here. We're going to set this equal to 2. And this is what I was talking about before. This is where it gets a little complicated because we can't solve this for x algebraically. Yes, you could put that in the calculator and find out where it crosses, but I'm hoping when you get ones like this, you can kind of just look at it and say, you know what would make sense? Try basic numbers like, what if x was 0? What if x was 1? What if x was -1? Just very simple numbers to see if it'll work. If not, well, then grab your calculator. That's fine. Hopefully you could tell that if x is 1, 1 cubed plus 1 is 2. So g of 2 is 1 because f of 1 is 2. It reverses, the inverses of each other. So now we know g of 2. So this becomes 1 over f prime of 1. F prime of x is going to be 3x squared plus 1. So then f prime of 1 is going to be 3 plus 1, which is 4. 3 plus 1, which is 4. So then our final answer is going to be 1 over 4. And that is the derivative of the inverse of f evaluated at 2. Okay, hopefully that makes sense. If you want to check out the proof, be sure and check out that PowerPoint we're going to upload. And if you have any other questions, be sure and let us know. All right, see you guys later.